Alright, here's my second example on expected value, and this time the table is not given to you. So I'd like to start by analyzing this question in a little bit different way, because it's good practice on some things that are coming up, and it's also a test of good logic. So in this problem, I have a coin, and I've created a game for you to play. Now if you'd like to play the game, it will cost you $1, so you'd have to pay me $1 to play this game. And what will happen is I'll flip the coin. If it lands on heads, I will give you $3. And if it lands on tails, you lose. You don't get anything from me. So what I want to do is I want to analyze this problem here with a tree diagram first, because it's a good chance for us to review tree diagrams and a good chance for us to take a look at what's coming up here soon in probability. So in this problem, I'm going to flip a coin. So when I flip a coin, you should know that there really are only two results or two outcomes that can happen. And those two outcomes are heads could occur or tails could occur. Those are the only two things that can happen here. And let's look at this. If I flip a head, then let's talk about what happens here. If I flip heads, let's go to the problem. It says if it lands on heads, if I flip heads, okay, you will get $3. So the outcome is that you're going to get $3, but I want you to be really, really careful. The outcome, when you're done playing my game and you go home, you don't really have $3 more than you had before. Okay, you need to realize that you gave me $1 already to start this game. So actually what happens is if I flip heads when I flip the coin, the outcome for you is actually $2. Please make sure you know why that's a 2. $2 because I gave you 3, but you gave me 1, so you actually only gained $2. That's the outcome. Okay, now let's look at what happens if I flip a tails. If I flip tails, okay, go up to the top again. If I flip tails, you will get $0. But again, you need to be careful. I don't give you anything. Please remember, you gave me that dollar. So actually, can you think of what I'm going to write right here after tails? The outcome is you lost $1. So I'm going to write -1. That is the outcome. So in this problem, there are only two outcomes. One of the outcomes is that you gain 2, you have gain 2, or you lose 1. Those are the only outcomes. So this is kind of a tree diagram approach, but on the side here, I'm going to create my little table. All right, I'm going to have outcomes and probabilities. All right, outcomes and probabilities. So there are only two outcomes. The first outcome is $2, positive 2 for you. And the second outcome is minus $1. You lose $1. Now the probability, let's talk about this. The probability that the first outcome happens is the probability that I flip heads. And you should know that the probability of getting heads is 1/2. So over here the probability is 1/2. I'll write that as 0.5. And then the probability of getting tails is also 1/2. When we flip a coin, probability of getting tails is 1/2. So probability over here of getting tails is also 0.5. Okay, so this is kind of our probability model. It lists the outcomes and all of their probabilities. And that's basically what we used in the last problem to solve expected value. And that's the next thing I'd like to calculate. I would like to calculate expected value. So let's talk about that. Expected value, if you remember from what we've talked about in the last example, or if you looked in the book, expected value is calculated by multiplying all of the outcomes by their probabilities. So the first outcome is 2, and the probability that that happens is 0.5. The next outcome is a -1, and its probability is 0.5. And after we multiply all of the outcomes times their probability, we should add the answers. So let's take a look at what happens here. Expected value, 2 times 1/2 is 1, plus -1 times 1/2 is a -1/2. And when I add 1 plus -1/2, I get 0.5 or half. That is my expected value for this problem. Now let's talk about what that means. That means in the long run, if I were to play this game over and over and over again, in the long run, the average thing that's going to occur is zero point 0.5, which is 50 cents. The average thing that's going to occur if you played this game over and over and over again, all day, all night, for years and years and years, on average, the outcome's going to be a positive 50 cents. That means in the long run, you will, on average, make 50 cents per game that you play. It doesn't mean you'll win 50 cents the first time. It doesn't mean that you're guaranteed 50 cents if you play 3 times. It just means if you play over a really, really long period of time, on average, you should make 50